Hi, I'm David Ewing Duncan. I'm here in San Francisco, and a few years back I set out to tell a story as a journalist about all of the great new developments that are out there in biotechnology, devices, the whole area of what I call personalized health. And it's called the Experimental Man Project, and I've been genotyped, all my DNA tested, brain scans, environmental tests. But what I'm here to tell you about today is the latest round of testing. And it involves a kind of fun little experiment which started with me having blood drawn right here in San Francisco and sent to a company up in Wisconsin called CDI. And this company, once my blood arrived, cracked it open and created, essentially in a petri dish, some little beating heart cells which are identical genetically to my heart cells. Now, this process is called induced pluripotent stem cell technology. And what happens is they take my blood cell, they, through various bioengineering techniques, reverse it backward to a state that's called pluripotent. And pluripotent stem cells are what occur just after conception or just after fertilization of a human egg. And in the few days after that event occurs, you have cells that are then capable of growing into any cells in the body. So what this process at CDI does, it reversed my blood cells back to pluripotent cells, which were then further bioengineered into heart cells. And what CDI did after that was run a bunch of tests, which essentially tried to link up personalized health. And what I mean by that is diagnostics, ways of seeing or predicting what my health future might be, how I might interact with drugs, using these heart cells, and eventually it'll be brain cells, liver cells, lots of other cells. There are 208 cells in the human body, types. And one day we'll be able to test drugs to diagnose disease and illness using these little tiny cells. So that's what I set out to do, and that's what we're going to tell you about today.
I've given countless presentations in public settings where I have a movie of these cells, these human heart cells beating in a dish, and literally after I put the movie up, I don't really need to say anything further, because the ability to represent that biology in a dish and be able to look through a microscope and potentially look at your own heart cells beating in a dish is nothing short of miraculous.
David Ewing Duncan's very knowledgeable about personalized medicine. So what we wanted to do is, by showing what our heart cells could do, proving it, David could get that message out to a wider public beyond the scientific community.
For David Ewing Duncan, we were able to take a blood sample, have it shipped to CDI, and we were able to reprogram his cells back into induced pluripotent stem cells, or iPS cells. We then expanded those cells into a large enough quantity such that we could put them into what we call the differentiation process. We then were able to make his heart cells in relatively large quantities and at a purity of above 90%, such that we could really study cardiac behavior based on his individual biology. We then tested all of the electrophysiological properties of his cells to make sure that in a sense his cells beat appropriately, that when we put drugs on his cells that caused them to speed up, that his cells did indeed speed up, and when we took that drug away, his cells came back down to a basal normal level. We then followed that up with looking at a variety of different drugs to understand if there were other biological properties that were found in his cells that may predispose him to toxicity for certain types of drugs, but not necessarily just on the beating capacity, but also as it relates to drugs that, for instance, like cancer therapies that have been known to show cardiotoxicity, that we were able to recapitulate that in the dish as well. So in a sense, we now have a biological fingerprint of David's cells, such that we could, in essence, if he was going to go on a new drug that could have effect on his heart, that we could test that prior to him taking the drug. We've confirmed that David Ewing Duncan does have a heart. It can be reproduced in a dish, and it does respond normally to drugs that we would expect it to have an effect on.
This is the first time we have all the building blocks of the human body in our hands. And It's such a broadly enabling technology for that simple fact that I can't even predict what it's going to be used for 20 years from now. And I think there's tremendous parallels to the early days of recombinant DNA. There was the same kind of social uproar followed by compromise, followed by getting on with it. And scientists, if you ask them in, say, the middle 70s, would the human genome be sequenced ever, let alone within their lifetimes? They'd be highly skeptical of it because the technology was such that you'd never think that would happen. Yet the human genome is done today. It kind of closes the loop on trying to understand how the human genome works, because right now we have the whole genome sequenced, but there's a huge amount to understand how it functions. And being able to actually get the cellular building blocks of the human body in tissue culture means we can finally work out, okay, so how is this change in the genome associated with function?